Since April 1990, the Hubble Space Telescope has expanded our universe with its never-before-seen views. Hubble's awe-inspiring images have not only helped us to better understand our universe, but redefine the way in which we see it. However, shortly after the telescope's deployment into space, scientists discovered that the bi-stem booms supporting Hubble's solar arrays would periodically shake as a result of the extreme temperature changes that occurred in the space environment. This movement would then jar the telescope, resulting in misalignment with the telescope's target. Goddard Space Flight Center, the NASA center managing the Hubble project, contacted Glenn Research Center to help solve this problem because of Glenn's expertise in materials and environmental space durability.
Glenn was invited to participate in some of the Hubble problem-solving issues because we had expertise in atomic oxygen, and they needed some testing done, and there wasn't any place else that they could go. And we had a pretty strong track record of publications and activity in atomic oxygen testing, and ultimately we did UV radiation testing as well.
The issue that the team at Glenn Research Center addressed was the survivability of the thermal control material being used on the bi-stem of the solar array, specifically the survivability to electron bombardment, atomic oxygen exposure, and vacuum ultraviolet radiation. All environmental factors that can degrade the material being used. Based on our testing and our results that we found, just using the base material alone, the aluminumized Teflon, was sufficient to perform the function needed.
The work that I did was to characterize the thermal shields that were durability tested at NASA Glenn and Goddard Space Flight Center and exposed to atomic oxygen, UV radiation, and thermal cycling. I found that the coating that we were planning to use as the primary design was falling off or coming off in little pieces, and this would have been a real problem for the telescope if that material had been used.
NASA Glenn had unique capabilities in that we had the ultraviolet, the vacuum ultraviolet facility where we could expose the bi-stem materials for the servicing mission. They wanted to take a look at the different coatings and see if they would work or if the ultraviolet radiation would degrade those. So we looked at those candidate materials in our ultraviolet facility.
The work I did with the Hubble Space Telescope mission was to take ideas from the research team for developing materials to extend the lifetime of the Hubble spacecraft and test these materials in a simulated environment that would accelerate the life testing of these materials and automate the facility so that the facility could actually run 24/7 uninterrupted.
The most challenging aspect of working on Hubble was meeting the aggressive schedule. For example, to prepare for servicing Mission 1, we had less than a year, significantly less than a year, where we had to do a major upgrade of our ultraviolet test facility by including heating lamps, and we had never done that before. And we needed to get the test rig to work, we needed to take research data, we needed to analyze samples, and return results back to Goddard to prepare for that mission.
After the second servicing mission, they found large cracks in the outer layer of insulation on the Hubble Space Telescope. And so Goddard put together a failure review board with some experts from across the country, and they invited 3 members from NASA Glenn, myself, Bruce Banks, and Joyce Dever. So we were part of this Hubble failure review board, and we did 2 different tasks primarily. One was determine how damaged the material is on the telescope, and to come up with a replacement material that they could take up during the next servicing mission.
I was brought in as part of the team to try to figure out why this had happened and how we could fix it. My role was to look at some of the high energy radiation to see what was going on. So for instance, was it X-rays? Was it gamma rays? Was it ultraviolet? I looked at all of those in simulating the environment to try to figure out what we could do on Earth that would give us the same kind of degradation that we were seeing in space. What we found was that it was actually a combination of things. It was both the radiation and the thermal cycling, the heating up and cooling down, that if you had either one by itself, you didn't have a lot of damage. But if you had the 2 together, that's when the Teflon multi-layer insulation failed.
Additionally, as a result of the failure review board, the team made recommendations for replacement material to be installed during servicing mission 3A. And after servicing mission 3A, I also had the chance to analyze materials that were retrieved during that mission.
The work we did was important because we were able to tell Goddard how damaged that MLI installation should be when the astronauts were going to go up and do an EVA, and they used that information to develop the rules that govern what the astronauts do during the EVA.
The issue I addressed for servicing mission 4 was the brittleness of a quilted blanket that was on the Hubble Space Telescope. Earlier it had gotten exposed to the environment, so there was a fear that when the astronauts were working on servicing mission 4, that the parts of the blanket would break apart and drift in front of the camera or get into the electronics. So I looked at the material on the ground and used some space environment projections to determine that the blanket would not be brittle for this forced servicing mission.
People went away feeling pretty comfortable with the recommendation, and it was very defendable to senior management because you considered every issue, every person, and all the materials. So there was not much doubt in anyone's mind that we gave the best recommendation we could.
Basically, if you have the opportunity to work with anything for the Hubble Space Telescope, you know, you feel like you played just a small part, but it's just, you know, it's such an accomplishment for NASA.
It was a great experience for me. I've taken a lot away from that in my life since, away from NASA. But I have a lot of great memories and a lot of appreciation for all the people on the team, and we remain close to this day.
I feel very fortunate to have worked on a mission that has had such a sweeping impact on our understanding of our solar system and the universe.
Well, working on Hubble, it's like what we do every day. And so as we were doing it, it's just kind of the same old, you know, what we do. But every once in a while, when you see the images from Hubble and you realize that, you know, gee, I had a small part in the fact that Hubble is still working. That's really great. Makes me smile.